All right, now that we've seen converting from polar form to rectangular form, let's go the other way around. Let's go from rectangular form to polar form. So I'm going to have a point here. Let's say we have 9 square root of 3 comma 9. And I want to know, what is this polar coordinate? Well, this is a little bit more tricky simply because there's an infinite amount of polar coordinates that could represent this. So let's kind of think our way through this. So first and foremost, I'm just going to kind of draw out what I'm doing. Drawing a visual really helps a lot of people. So 9 square root of 3, and the 9 is going to be up in here somewhere. So 9 square root 3 comma 9. And I'm going to draw myself a reference triangle. Because when in doubt, I can always go to that, what we've learned in trigonometry. So my x distance is 9 square root of 3, and my y distance is a positive 9. And here's my angle. Well, before, this is kind of how we got our unit circle. This is my radius. So to find my r, I just have to do Pythagorean theorem. I could say r squared equals my x squared plus my y squared. This gives me r squared equals 9 square root of 3 plus 9. This is squared and squared. This is going to give me r squared equals 81 times 3 plus 81. Oh, what's that math come out to be? 261. R squared equals 261. And then my r is plus or minus the square root of 261. But because of the radius, well, let's leave the plus or minus here for a second. And I'll explain why, probably in the next example. Let's leave it here for a second. Well, let's break down our 261, because I want to have it in simplest form. I know 3 goes into 261 87 times. I know 3 goes into 87 29 times. So this is really plus or minus 3 square root of 29. So I have my radius. Now I ask myself, how do I find this angle? Well, I know my trig functions, and I know tangent is opposite over adjacent. So I can actually do my theta is going to be arc tangent of my y over my x. So to find theta, all I do is plug it in a calculator. Or if it's on the unit circle, we just do our unit circle. So I've got 9 over 9 square root of 3. My 9 simplify. Now I have arc tangent of 1 over the square root of 3, which is actually, if I rationalize the denominator, I get arc tangent of square root of 3 over 3. This is pi over 6. Oh, I ran off. That's pi over 6. So, now I have to ask myself, okay, well, let me just look. This is in quadrant 1. That's pi over 6. So I'm going to use the positive radius. So one of my answers would be 3 square root of 29, comma, pi over 6. Now, I could also go on the other side of the pole and do a negative. So I can use the negative if I wanted to. I would do negative 3 square root of 29, and I would just add pi to this. So I would do 7 pi over 6, and there is another coordinate. I could do a lot of different ways of getting these coordinates, but this plus or minus actually does mean something because you can have a negative radius in the polar system. So if you give me a positive or the negative, all I do is make sure your angle is correct and you're still going to be right. All right, let's do another example, but this time I'm not going to draw it actually out. We're just going to use some pretty basic formulas. Let's say I have the point -1 negative square root of 3. All right, and I want to know what the polar coordinate is. Well, in the first example, we drew it out and kind of showed you where you were getting, how you can get your r and how you can get your theta. Well, those formulas are going to be r squared equals x squared plus y squared. And then my theta is going to equal arc tangent of, let's see, y over x. All right, so I have an x, I have a y. To find my r and my theta, all I have to do is plug and chug. I'm going to get r squared equals -1 squared plus negative square root of 3 squared. This gives me 1 plus 3. This gives me 4, and that's r squared. Therefore, my radius is going to be either a plus or minus 2. The plus and minus only depend upon what angle I choose. I can use either one of them. It just depends on what angle I choose. All right. Now, let's see. Arc tangent, so I'm going to plug it in. Arc tangent of negative square root of 3 over negative 1. This gives me arc tangent of square root of 3. This gives me pi over 3. Okay, now I need to actually stop and think for a second instead of just blindly saying, oh, the positive goes with the positive. I'm going to come back and look and recognize this is in quadrant 3. That means my angle for the positive has to be between pi and 3 pi over 2. So if I want to do pi over 3 is clearly not between these angles. So one of my points, if I want to use the negative radius, is going to be my pi over 3. Because pi over 3 is in quadrant 1, but I can go through the pole and I'll be back in quadrant 3. The other answer would be 2, but now I need to add pi to my pi over 3, and I get 4 pi over 3. Both of these are your answer, but you're going to have to pay attention to what quadrant this is in and look at really what the range of the angle you're looking for to make sure you get the correct, the positive or the negative radius. Hi, I'm Mr. Buzzer, and these videos are supplemental instruction for my students. If you found the video enjoyable, make sure you click the like button and click subscribe, as well as the bell for notifications to receive future videos on high school mathematics.